Welcome to the Noble Ape podcast, Ape Reality. I'm Tom Barbalet, and today I have the real luxury of talking with Bob Mottram. Hello, Bob.
Hello, Tom.
It's wonderful to be able to talk with you, and I brought you on because I wanted to have some kind of code review associated with the breadth of changes that you put in, but particularly with the universe directory. So for folks listening in who want to read along with the code, we're doing it with the 0.692 version. But Bob, I'll throw it over to you, and you can start the walkthrough.
Probably the best place to start would be universe.h, which gives you some of the structures involved. If you scroll down to, in the region of Noble Being, around line 367 is where it starts. There's quite a few if-defs here, and this is where I've mostly made additions. So you've got things like parasites, honor value, and so on. Now I can go into a bit more detail about what those mean and what they refer to. You can probably see that structure is fairly expanded compared to what it was in previous versions. So if we start at the beginning, I suppose, if you have a look at parasites underscore on, under there we've got a couple of n byte values. The first one is parasites. Now this just refers to a number of parasites which the ape can carry. And the idea behind this is really just to add a little bit more interest and have a bit of maybe a bit of symbiosis going on between a sort of parasite and host relationship. So parasites will consume a certain amount of the ape's energy over time, and all this byte value refers to is just to like a number of parasites which are attached to and growing on the ape. The honor value is also associated with parasites in that apes can acquire honor, which is a kind of social status, you can think of it, by grooming each other and getting rid of parasites. There's also the possibility for parasites to hop between apes if they're sufficiently close together. That's the actual code for that is covered social. So if you go to social.c, do a search for parasites on. I've got a routine here called social underscore groom, line 354. This is the grooming part where we're actually getting rid of parasites. And you can see under lines 367, it's just checking whether the number of parasites on within the parameters for social groom, you've got two beings which are close together. The distance they are apart, whether they're awake or asleep, level of familiarity, and just a pointer to the simulation object. Going back to 367, if the number of parasites hasn't reached its maximum for the byte value, we just calculate a probability, paraprob, which is just a random number. And if it's less than a certain calculated amount related to the environment and breed, then we just add a new parasite. Now, it should be noted that I think in order to be able to do that, in order for social groom to be called, the apes B0 and B1 already need to be pretty close together. So that check is done elsewhere. I go down to a bit further down to 376. This is where the energy of the ape is sapped by parasites. So you can see that the number of parasites on B0 is then just multiplied by some cost value, some energy cost, and that gets subtracted from the energy for that being. Now, as I've mentioned before, parasites can also be transmitted between apes. So you can see at line 378, if the distance between apes is quite small, less than 3 in this case, and the adjacent ape doesn't have its parasite's value saturated, so it's below 255, then a parasite can hop from B0 to B1. So we just increment the number of parasites on ape B1 and decrement the value on B0. In this way, parasites can kind of move around in the population, be a little bit mobile. The parasites themselves aren't modelled in any more detail than that. Potentially, they could have their own metabolism and genetics and so on. But just as an initial idea, just to keep things simple, and yet still add a little bit of spice to the simulation. We can just have it in this very simple way where it's just a count of parasites, not really going any deeper than that.
No, I think that's a really interesting idea, actually, Bob, almost having a noble parasite simulation as well within it. And certainly from the stuff that you've added initially, that's very doable. Yeah. But I'll let you continue.
When I was initially reading about Noble Ape, it was initially mentioned that there were these fierce felines as well. So you would have some sort of relationship between the apes and some other entity. And because after just scanning through the code, it looked like the felines had been taken out.
Around 97 they were removed because they were just too predatory.
Yeah, I thought it might be an idea to have some sort of other entity in the simulation where you've got some sort of symbiosis or some sort of dynamic going on between these two entities, which might add a little bit more dynamics to it. Just carrying on with that, I suppose, if we head on down through the code, you can see that line 394, there's a tendency to groom depending on how familiar apes are with each other. We're calculating a sort of grooming probability on line 392, groom prob, which is just a random number. And then checking this on line 396 against a value which is calculated based on the familiarity between the apes. And this is in part based on genetics as well. So you can have a genetic influence which indicates whether the apes tend to groom more or less, which might add a little bit of interest to the way that they evolve. In that way, the whole simulation can gravitate towards or settle towards a situation which kind of balances out the energy withdrawn from apes by parasites. So they can find some sort of happy balance between carrying around parasites and spending energy in grooming other apes.
Grooming should take some energy in the description that you gave, but I was wondering where that energy for grooming is taken from.
Energy for grooming, you mean?
Yes.
At the moment, there isn't any explicit.
Okay, so that's something to add, I guess. Energy for grooming, so that could be, because that's the penalty of being a good groomer, perhaps, that you.
That's right. Yeah, it could potentially be added as an extra explicit piece of energy. But there is a kind of implicit energy that's consumed just because the ape is stopping and grooming another ape.
True.
Whereas it could be continuing and eating or doing something else.
True.
So it's kind of implicit in that way, but there could be some explicit energy involved with doing that, yes. And as far as the energy is concerned, it's if you have a look at line 376, that's where the energy is getting sapped by parasites.
Yeah.
So anyway, just going back to line 401, this is a little other bit of the stuff that I added, which is to do with memories. So it actually adds a memory to each ape that a grooming incident took place at the current time and the current location. It just adds if you have a look at social memory, what we're adding is B0, which is the pointer to the ape, an event type, event underscore groom. This 16384 plus 100, I think from memory, I think it's just a degree of pleasantness or unpleasantness.
Okay, so I wasn't sure about that, actually, reading through it. So is this almost like a hierarchy to the, or not a hierarchy, but not even a probability, but some heightened or lowered state of memory that you're offering here?
You could say it's almost like a reinforcement sort of value, whether it's a positive or negative sort of, whether it has positive or negative feeling for the ape, you could say.
Okay.
And we're also just passing the date and time, the gender as well. And also a bit further down, line 411, also calling the social meet function. I'll have to have a look at that to remember what that one's about, but I think it's just a general function that apes meet, and it records the fact that the apes have met.
Should we have a look at social memory and social meet now, just to go through that stuff? So do you want to start with social memory?
Yeah, okay, social memory.
It's at line 60.
The value that I talked about previously, I think, is called effect. That's just sort of whether the incident is has a positive effect or negative effect. I think it's a byte 2 value. That's why on line 71 we're actually subtracting the 16384. 16384 can be considered the 0 value. Since this is a positive integer, I just set some value which is supposed to be the 0 value. So we don't have positive and negative. Now if I scroll down a little bit to 74, And what's going on here is between line 76 and 82, what we're doing is we're actually fading the affect associated with each memory. So all of them are fading towards 0, which in this case is 16384, either by adding if it's a negative effect or subtracting if it's positive. And line 83 to 88 is actually not related to that. It's just picking out whether the event which this memory is related to, whether there is an event of the same type within the episodic memory. And if so, it's just keeping a track of that. So you can see line 87, it's just keeping track of the index number of the memory. If we go down a bit further, we can then see whether it's replaced or not. If it is replaced, if we look at 104, then it adds all the information to a new entry within the episodic memory, indexed by a value called replace.
Do you want to go just through them now, go into drives and meet and what have you, one by one?
Yep, okay, so I've got a social meet. Now, it could be argued with that previous update of the effect that maybe that should be separate from that routine in its own routine, which is updated once per clock cycle. So at the moment, the effect is sort of fades every time that routine is called, and it could potentially be called multiple times per cycle. So that's maybe something to do in future, I think.
Certainly.
Take that out, have it in its own routine. So anyway, going back to social meet, line 228, here we've got the one being meeting another with the information about the pointer to the being, and we've got the name, pigmentation, belief, and the simulation pointer. Now, belief here just refers to, usually just refers to the state of the other ape that's being met. So it could be swimming or grooming or doing other things, eating. Line 246 onwards, I'm just looking at whether this being's been met before. So you can see line 255, then if the being's been met before, and it just marks it as met equals 1, just to indicate, and stores the index within the social graph. If the being hasn't been met before, then line 265 onwards, see that it gives it an index, stranger index, which is just the maximum index within the social graph array, and we have an initial sort of prejudice whether the being that's being met is a friend or foe. One way that we define this is just by the similarity of the family name. So here we're just doing a check of the line 274, just doing a check of the first and second parts of the double-barreled family name, and just adding some value to indicate whether it's friend or foe based on that. So if it shares one part of the double barrel, and we get a bit of friend or foe, a bit of friendliness, you could say. If it shares both the names, then we get double that amount. And we can also bias based on whether you like the look of the other ape that you've just met. So this is where genetics comes into it a little bit with the pigmentation, the colour of the fur of the ape, line 282. So we have a sort of value which indicates the colour, you could say, and we're just doing a subtraction between the kind of colour that the ape prefers, which at the moment is purely genetic, there's no experience related to that, and the colour of the apes that's being met.
It would be interesting to add experience to that, actually, and relatively easy.
Yes, it would be. At the moment there's no experience, but one little quirk that there is that there's a difference between male and female. So you can have sort of sexual dimorphism, where there's a difference in preference for colour between males and females. So say green males prefer blue females and blue females prefer red males, something like that. It doesn't necessarily have to be symmetric. So line 290 we just adjust the friend or foe up or down a little bit depending on that preference. So you could have sort of the origins of some sort of vision-based prejudice against other apes based on their fur colour, which over the long term might have some interesting effects. If one thing I haven't done is actually plot out different colours of apes within the population. That might be interesting to have a look at. You might have battles going on between different coloured apes, which at the moment I have no idea whether that occurs or not, but it might, conceivably, over time.
So in terms of the feedback that I got from the SRI talk, and this is certainly something that I think about quite a bit, is how do we actually take, more importantly, I guess initially, how do I actually take all this information and translate it into something which is trackable? And I know you've had some experience with the web server to do some of that. What's your thinking in terms of how to actually track this stuff?
At the moment, the stuff that you see within the web server is just purely based within web.c, so it's not within the main body of the code. Possibly you could have some structure which is monitoring various parameters, so things like parasites and average age of the population.
It was interesting because, certainly I put that out to the mailing list that statistics and internally tracked statistics within Universe is probably the next phase, as far as I can see.
You could either have that maybe within the simulation object or just have it within its own statistics object.
Certainly.
That would definitely be a good idea, I think. And within the being meet, it's just keeping track of the location where the other being was met, line 306, just keeping track of the XY coordinates. The belief, which, as I mentioned earlier, is usually just the state of the other ape. The time when it was met, which comes from the simulation objects, level of familiarity, and a friendliness value, whether it's friend or foe. So if we're meeting other apes frequently, then line 318, we're actually incrementing gradually the friend or foe value. So it's, if you meet another ape that you're initially hostile, but if you meet them more frequently, then you might become more friendly towards them. It seemed like a kind of reasonable sort of heuristic. Overcoming prejudice, you could imagine it as. And that just about covers being.meet. All we're doing at the end of being.meet is just returning the index within the social graph array.
So we've done social slightly out of order. Do you want to jump back to social drives, which is at, I think, 120?
So the idea of having drives originally comes from ethological studies of animals. Where I first encountered things like drives was in robotics from the work of people like Cynthia Breazeal, trying to simulate emotions of different kinds within her system, which is described in a book called Designing Sociable Robots. I think she had a three-dimensional system. I forget exactly what the dimensions were. I think there were things like valence and stance. So that's kind of where I got the idea from, that you might have certain basic drives which the being is trying to maintain within some homeostatic regime within an acceptable tolerance. So what I've done is I've added a few drives. We've got hunger, how hungry the ape is, a social drive, which originally, from my perspective anyway, comes from social drive from the MIT stuff, Cynthia Breazeal stuff. And you might have a drive where if you haven't met other beings for a while, you become kind of lonely, and you might want to sort of have a social drive which encourages the being to meet up with other beings. A sex drive, fairly self-explanatory, I suppose. If you don't reproduce, you'll eventually die out and your genes will be lost. So there's a fair bit of code associated with that. And fatigue as well. So just you might want to minimise the amount of excessive energy expenditure to try and survive as long as you possibly can, and surviving as long as you can means more opportunities to mate and more opportunities to pass on your genes. So if I have a look in more detail at the code behind those, on hunger, line 130, there we're just looking at just gradually incrementing the level of hunger, line 132, and there's a bit related to sex drive, which I'm not sure I remember. Something's related. Maybe it's to do with a clash between hunger and sex, something like that.
Well, maybe when the ape is more hungry, the sex drive drops down, basically. So,
right, yeah. And I think I put that in because they tend to spend a lot of the time feeding. Otherwise, they don't tend to mate very often. Yeah, I think that's why. So if there's quite a high sex drive, then that tends to inhibit the drive towards hunger.
So is the potential within this drive's dynamic that it will actually work against the underlying biology? I mean, the previous coding of Noble Ape had hunger meaning literally an energy level where the ape stopped to eat. But what you seem to be adding here as well is an additional dynamic where an oversexed ape may actually potentially starve to death because they don't care about eating anymore.
Well, potentially, I suppose maybe that could happen. but I think the way that it's set up at the moment is sufficient so that they tend to eat often enough, at least.
What additional drives would you like to, or could you see being added? Because, I mean, this seems like a small number of possible drives. Have you thought of any other drives?
Not that immediately come to mind, but I suppose there could be other drives. I suppose you could diversify the social drive into things like other aspects of communication. So you might have drive for certain types of communication or certain types of sociality.
Well, you have the concept of alpha, and that in itself could be a drive.
Yes, it could be potentially. I mean, each ape doesn't really know who the alpha ape is, the alpha female or the alpha male. They only kind of look at each other's honour value locally. But potentially there could be something which is a bit more global, maybe, where each ape knows who the alpha male and who the alpha female is. Maybe there's some drive related to that.
I was thinking almost more that it could be an internal drive associated with... It wouldn't... Yeah, you're right. The alpha is very much described as a unique entity, whereas I guess what I'm thinking of is notions of gregariousness. I'm trying to think of how that would actually... But certainly, yeah, there seem to be other drive options, and the way that they're mapped will be very interesting. I'll let you continue through the code.
So at the moment you could say that the simulation knows who is alpha male and alpha female, but the individual apes have no idea. They're not at that level of organisation at the moment. Although they do have a social graph and they have degrees of friendliness between other apes that they're familiar with.
Do you want to talk more about social drive, or do you want to move on to social network?
We could move on to social network, I suppose.
Okay, 327.
So this is quite a short little function. What we're doing here is just having a look at getting the pigmentation preference from the genetics, line 339 or 341, and then we're passing that into social meat. I forget the reason why I separated out being meat from social network, but they're basically doing the same kind of thing. Social network is just a wrapper around being meat, really. It's no doubt because being meat needs to be called in different kinds of situations from the social network thing. So that's a pretty short function, really, which is really just a wrapper.
So we've looked at social groom, I believe. What have we got left? Social squabble at 450.
Okay, squabbling. Within social squabble, we're having a look at the difference in locations between the two apes. One of the apes is same_being, and the other one is local. And apes tend to squabble if they're from different families. So line 463, you can see we're doing a check on the family names. If the name is the same, then much less likely to squabble. So line 466, going beyond that, we're actually turning towards the ape that you want to squabble with, or potentially squabble with. We're getting an aggression value which is purely from the genetics, line 471. And we're doing a little bit of jiggery-pokery, line 472, just to make females a little bit less aggressive than males. Potentially the aggression value could be diversified a little bit within the genetics. So like the pigmentation preference, you could have a separate gene for male aggression or female aggression. But at the moment it's just one single aggression value within the genetics. We're just kind of tweaking it here, 473, 474, to reduce it a little bit for females. Line 474, we're just getting a random value and then comparing it with a calculated value to see whether we want to squabble or not. So it's a sort of pseudo-random squabbling. And then we get into the fight, line 477, looking at who is the victor and who is the vanquished. Do a bit of a calculation, line 481, we're doing multiplying the energy for the two combatants by some random value, and based on that deciding who is the winner. So you can see by default the victor is the local being, line 477, but if that condition is true, then line 483, the victor is the opposite being, same_being. Then if we go down a little bit further, and this is probably why I separated out the social network from social meat, line 489, you can see that the social meat function is called for the victor and the the vanquished. And the reason for that is so that we can add an event to the episodic memory, saying that we had a fight with another ape at a certain time in a certain location. And you can see that being added as well, line 403, social underscore memory. Going down a bit further, line 515. Here we adjust the friend or foe value depending on who won the battle. So if you fight against somebody and you lose, you're going to be less well disposed to them than you were previously. So you can see that's line 517, reducing the friend and foe value a little bit.
Bob, in terms of the actual friend and foe value, I remember the 40 number associated with one shared component of the family name. Have you thought, in terms of these numbers, about what they actually mean? So when you say 20 here, do you have a sense of the kind of quantization?
These values added are really, they're just sort of hand-coded values. They're not really coming from anywhere. I think in this case the friend or foe value is it's either a byte or it's a double byte. So it doesn't really matter how much is added or subtracted from that, as long as it's within a suitable range, I suppose. But potentially these hard-coded values could be genetic, or they could be modified by experience or something like that, potentially, to make it a little bit more interesting, if that's what you were thinking of.
Yes, I was thinking that, I try to get a sense of quantizing values through the simulation, and you've had a lot of values that don't seem to implicitly have any degree of quantization, but as you say, if this is something that can be defined through future runs of the simulation, or as we start generating vast quantities of statistics and exploring these statistics and then scaling accordingly, I'm more than happy to do that. My aim is really to turn a lot of these into named constants.
Yes, they could be either constants or, as I mentioned previously, there could be maybe adjustable from experience or come from the genetics. Might be quite interesting to add it to the genetics to see what happens, but as we get more detail on the statistics of it and be able to do more analysis, be able to see what sort of extent, what sort of effects these values have, and tweak around with them.
Certainly.
So, just describing the code like this, all of these things could be potentially graphed in the server or within a separate structure. You'd probably get some interesting stuff over time. So, heading on down the code. Actually, just going back to that Victor and Vanquish stuff that I was looking at previously, I think it's the case that if you're the victor... Okay, if you're the victor, you disrespect the vanquished. If you're the vanquished, you respect the victor. So that's the situation with that. I think previously I described it wrongly, which seems like it ought to make sense anyway. But
that's kind of interesting. You respect the person that's beating you, I guess.
Right. Yeah. Potentially, if those were attached to the genetics, then it doesn't necessarily have to be like that. It could be that over time, if the dynamics of it works out, it might be that you disrespect the person who was beating you. It might be that the polarity is reversed or something like that.
Or even more curiously...
I suppose that you could say that these hard-coded values just come from my own prejudices.
Yeah, it's not just... both values could be reversed in a very curious way, that you actually gain more... there could be apes that, as they brutalise the other ape, they gain more respect for them as well, so...
Yes, it could be, yeah. It could be, absolutely, yes.
Almost like being jumped into a street gang, really, that, you have to have this amount of violence, then we'll give you respect.
And the more you think about it, the more interesting it could get, especially if you add it to the genetics, because then you could have, subcultures which have certain particular kinds of values towards beating up other apes, and others that be more passive and more peaceful.
Yes, very interesting. Anyway, I'll let you continue.
Just carrying on, line 530. Okay, here we're just adjusting in addition to the friend or foe values, we're also adjusting the honour value. So if you're the victor, you gain a little bit of honour. If you're the vanquished, you lose a bit of honour, which is kind of similar to the idea of social status. And again, the same could apply for incrementing or decrementing the honour value as it applies to the friend or foe value. And it would be interesting if those were also genetic. Continuing down, line 534, if we're sufficiently far apart, then, okay, if we're quite close and we're in a fight that's quite grisly, then we're decrementing a fair amount of energy from each ape, both from the victor and the vanquished. It's line 536, 537.
So the upper code is more like kind of chest beating, isn't it? It's like two apes coming together,
That's
not
right.
actually coming to blows.
So this first condition, line 534 to 540, if we're spaced some distance apart, then it is like chest beating. But if we go into the other part, 542 to 550, then it's a more vicious attack and you lose more energy. It's more of a fist fight. And also, a little tweak of the code, line 546 to 550, depending on who won the fight, we're actually swapping the social status. And the reason why I added this is it adds a little bit more interest in that if you're a low status individual and you take on a really high status individual, you can potentially sort of leapfrog up the status hierarchy to the top of the heap, so that there is potentially some benefit to be had, some advantage to be had from maybe taking on the hierarchy for low-ranking individuals. Again, potentially that could also be subject to genetics. There could be maybe just an on and off switch for that within the genetics, or something like that.
The idea of honour in an abstract sense here is very interesting, Bob, because as you say with regards to the alpha male, this is something that the simulation knows about, but the apes themselves don't actually know about. And this notion of honour... Sorry.
That's right, yes.
This notion of honour really doesn't have because you could have almost... you could have multiple systems of honour that different apes used and were unrecognised by other groups of apes. So it's an interesting... I think probably what it'll lead into is these kind of dynamics that you almost have orthogonal honour systems in many dimensions amongst many different...
Yeah, at the moment it's just purely one-dimensional, but yes, as you say, it could be multi-dimensional. There could be multiple types of honour, which are more refined and maybe associated with the genetics as well. Certain beings recognise certain types of honour and others don't. It's a pretty abstract value at the moment, and apes can detect each other's honour, but... as I mentioned earlier, they don't have any concept really of alpha males or alpha females. It's only something that the simulation recognises. So that just about covers it for that, I think, for social squabble.
So just the fleeing point, there's no change of direction. It's almost like they run past the...
Potentially there could be change of direction. That would add something to it, I suppose.
But it's almost like in humiliation they run past their victor as fast as possible.
That's right, yes, they just try and get away as quickly as possible. And you could say that a lot of these behaviours are just coming from my own assumptions about how primitive societies work. They might not be...
My only point of concern with that would be that the victor may have a posse behind it, and they may just run into the next wave of humiliation, basically. But no, that would be an interesting dynamic. Anyway, I'll let you continue.
Yeah. So I think a lot of these things could get a lot more interesting, and if these hard-coded values were actually in some way inserted into the genetics, then you could have more interesting types of behaviours which aren't just purely coinciding with my parochial view of what primitive society should be or should be like.
Certainly. So social eat, I think, was next on the food chain, so to speak.
So eating is fairly important for gaining energy, and what we're doing here, we're testing what type of land the ape is sitting on. So if we're above the watermark, which is being tested on line 581, and we have a look at what type of land we're on. So we're looking for grass, trees and bushes. And here we're just using the land operator to test what type of land is there. And then based on what type of land the ape is sitting on, we can increment the energy accordingly. So lines 594 to 606, we're just keeping track of the type of energy which can be acquired. Energy underscore grass, underscore bush, energy underscore fruit. And if we're in the intertidal zone, which is close to the water line, this is something that I also added into the land operator, just to make it a little bit more interesting. We can also have seaweed or rock pools or beaches, and also we can increment the energy based on that as well. So seaweed might have a certain amount of energy associated with it, which is consumable. And going down a little bit further, line 632 onwards, we can then calculate an absorption value, which is coming from the genetics. So we can have absorptions for different types of food. So you can imagine this as kind of the ape's metabolism and how well it can absorb energy from certain different types of food based on its metabolism.
The genetic response in all of these is from 0 to 7, isn't it? Am I right in that?
I think it is, yeah. Yeah, I think it is.
I had some concerns. There was one issue that I fixed with regards to, I think, they were slowing to eat almost instantly when the energy went below a graph, and it was based on the fact that the genetic spread actually needed something different from 0 to 7. It needed something like 4 to, what have you. I mean, there needed to be some additive part. And I think for some of these things, I mean, I guess zero in this case, what does it mean? That it just doesn't absorb any of the energy? Or
right.
Actually, there's a 1 there, sorry.
It means it's essentially intolerant of it, you could say.
Yeah.
Or it gains no nutrition from it.
Yes. It would be curious to even have allergies in here as well, but maybe the 0 case may be allergies or poisoning.
In the case of allergies or poisoning, you could maybe say that could maybe just make the absorption negative, perhaps.
Yeah.
Because then that's actually reducing the energy of the ape rather than gaining.
They'd need some feedback, however, in terms of maybe having an experience. Is there any kind of... So there's a social memory eating event that comes on afterwards, and what would be interesting is not just having the energy pass through, but having the absorption probably pass through. So they had some memory that they. It's interesting because you're really here describing the enjoyment of eating, which doesn't necessarily have to have any factor associated with the absorption, but you'd need some means of reinforcing epigenetically almost the enjoyment of food. Maybe that could be passed on from families through families and these kind of things as well.
Yes. Yeah. That would be quite interesting to do. And if you have a look at the third parameter of social memory, that's the affect value. And here we're just using the energy value, which is coming from the absorption, and using that as the affect. So potentially, in a situation where a certain type of food was poisonous or they were allergic to a certain type of food, if the absorption value was negative, then you would have a negative affect going into the social memory, and maybe potentially could learn to avoid that food or something like that. Although that's not implemented at the moment, maybe something for the future.
Very good. We come down to social mate.
Yep. Okay. So social mate. First thing in social mate, we're looking at the sex drives and looking at whether they exceed a particular value. In this case, 100. I think that's just a purely arbitrary value that I picked out. In order for two beings to mate, they've got to have a sex drive which is higher than a certain level. Otherwise, they're not interested. Going on to 690, we're then looking at the family names of the two apes, so that we can avoid having apes from the same family mating. That's just purely hard-coded at the moment. Maybe it potentially could have some genetic basis or be related to experience or something like that.
Yeah, that's an interesting one, actually, because there are...
It's an interesting question. How do beings avoid incest?
Yeah. Well, the typical descriptors that I've heard is that there are things that we pick up in terms of immune system feedback. So, for example, I mean, my wife and I actually, this is a complete aside. This is Stone Ape versus ape reality, but we have completely opposite immune systems, and you become. I've heard that basically people that you can establish through a variety of factors that you're not immediately conscious of, the immune system of your partner just through subtle placement, smells, pheromones, these kind of things. And it is quite curious that you can actually pick up this information through things that you're not immediately aware of. And it would be interesting, actually, if moving this from being hard-coded into something that was more ethereal but could show some interesting stuff.
Yeah. One thing that you mentioned, but which isn't included at the moment, is things like pheromones. One thing that I've heard in the past is that a way of avoiding incest is that you tend to not mate with beings that you grew up with or were familiar with within your early sort of formative years. And it could be that during your formative years you just become sort of acclimatized to a certain pheromone which is associated with the genetics of your close relations. And so when you're mating with other beings, you tend to go for other beings which have a substantially different type of pheromone.
Yeah, no, I think this would be interesting to represent. I don't think you'd even need specific pheromones, because you could just say that it was represented through aspects of the genetics, but then you could have genetic toning on that. So lots of possibilities here, Bob. Anyway, I'll let you continue. Sorry, this was an aside.
Yes, okay. Continuing on line 697. Here we're calculating, we're looking at the probability of mating. We're just basing it on, we've got a mating probability constant, mating underscore prob. We're biasing it based on the honour value of the other ape. So B1 honour. So that the purpose of that is just to sort of bias it in the direction of you tend to mate with, or there's a higher chance of you mating with beings if they have a higher social status, which kind of seems to, at least fits with my own understanding of how societies kind of tend to work anyway. But because that's genetic, it could be all over the shop, so it's really down to the dynamics of the whole simulation, whether that's a relevant factor or not, I suppose. Going down a little bit further, we just increment the attraction value between the two apes. So it's got past one level of, it's got past a couple of levels of conditions. So you can see line 694 and line 703. Every time it gets past a condition, we're just incrementing this attraction value. So you can say the more conditions it passes, the more attractive the other ape is. Then if you go to line 708, we're now looking at visual appearance. So this is based on the pigmentation preference, calculating a pigmentation preference. And then we've got a condition, line 723, which is just comparing the preference values, p-diff. So we just subtract the preference value, the genetic preference from the actual colour to get the difference. And then once we've passed line 723, as long as we're in the right sort of range, there is a condition there on 723. If p-pref is smaller than 8, then it doesn't actually care about the pigmentation at all. So it will mate with any ape regardless of colour. So it can decide, the genetics can effectively decide whether colour matters or not, and to what extent it matters. Again, we're incrementing the attraction on 726, and then we've also got a condition 729. We've got a pair bond threshold. So if the attraction value is above a certain threshold, then we continue on and eventually, hopefully, mate. So what might happen in cases here is that you might have multiple instances where social mate is called, but mating doesn't actually occur, but the attraction value is incremented nonetheless. And once it reaches a certain threshold, then we've got to a certain level where the pair bond is strong enough for mating to occur.
And the interesting dynamic is this is being done with two separate apes being calculated with two separate instances of the function, and the only way that it gets to actually conception is the being female.
The attraction does need to be largely mutual, I think, for mating to be successful.
Yeah. There are lots of interesting dynamics in here, though, Bob, that I think will need to be tracked in the future.
Yes, I agree, yes. So for a sufficiently close line 733, and being is of the opposite sex, look, it's female. This is male mating with a female. And we're checking the last conception date of a female to make sure that they're receptive to mating. Then we can proceed on to line 736. Here the female actually conceives. So we're keeping track of the conception date, which is today, storing the ID of the father and the father's honour value, which is important for social status, because social status can be inherited in this case. Keeping track of the name of the father, family name of the father, and also the genetics of the father are being stored, so that we can do the actual genetics function with the crossover and so on. We set the state of the being to reproducing, line 749, and reduce the sex drive back to 0, so that we're not in a continual state of mating. And we also set the goal of the being to none, Beings can have some sort of goal. It's fairly limited at the moment to sort of seeking out other beings. That's about the extent of it at the moment. I don't think beings have any other goals at the moment, other than maybe looking for other beings or perhaps searching for food, something like that. So that effectively, line 752 effectively terminates the goal if it was looking for a mate. And we also keep track of a memory of mating. Line 755 and 761. So we're doing that for both the beings B0 and B1. And if we go down a little bit further, line 733, you can see that if the conditions weren't met, they're actually decrementing the attraction value. So 774 and 780, reducing the attraction. Heading on to 783, just keeping track of the attraction value, and the attraction value is smaller than a certain. Just trying to figure out what this particular bit of code is doing. And we're just incrementing. Okay, that's the final bit where we actually add the attraction value down at 797. So we're actually just calculating some attraction value called attract, and then eventually adding it, or setting it at 797. And there's a bit of legacy stuff here. If we have a look at 801, condition with 801 to 807, if this stuff isn't enabled, if social isn't on, social underscore on isn't enabled, then we just mate immediately regardless, which is the old style mating.
Certainly, yes.
Which, if you're doing a simple simulation, you might want to keep that, conceivably.
Yeah, it's interesting actually in terms of what is maintained going on, because I think as the graphing and the statistics and all this kind of stuff comes through, then it will be a very different simulation in terms of how it's interacted with, and I think the simple simulation will probably fade away through that, and the EFF simply removes.
I can imagine circumstances under which you might want to keep a simple type of meeting. You might be interested in other factors.
Yeah. So moving on to social chat.
Social chat. So one thing that the apes do is they talk to each other occasionally. This is related to the sociality drive. So apes tend to talk to each other if they're friendly. So you can see line 832, where comparing the friend or foe value to a social respect constant. So it's got to be greater than some threshold to talk to other apes. Are we interested in their views or not? It's hard-coded, potentially could be genetic or learned, potentially. But at the moment, just one constant value. We're storing a memory of the chat, line 835.
So, Bob, a question. In terms of the social memory giving feedback, what we're doing currently is just collecting the fact that particular apes talk to other apes over long periods of time. Do they add anything in terms of... Oh, yes, they do add on a friend and foe. Okay, so there is some feedback in that. Okay.
Yes, there is some relation there, yes.
I'll let you continue, sorry. I got ahead of myself.
It's not massively sophisticated at the moment. It's fairly simple, so it could potentially be more elaborate. So, line 841. So we're just looking at the goal of the... If the goal isn't to mate, we're just choosing randomly. We're choosing an index. Reminding myself what this code means. Okay, so if two apes meet, and we have a goal to find a particular other ape, if we have no goal, and we're just choosing randomly, but if we have a particular goal ape that we're looking for, we can actually search through the social graph for that particular ape, line 847. So we're just looping through the social graph there, looking for the index of the ape that we're interested in. But if not, we're just choosing randomly. Checking whether we've met that ape before, 861. If we have met the ape before, in other words, if it's within the social graph, and we break out of that loop, we use the index value for that loop. And the next condition, 870. Social size is the maximum size of the social graph. So it's the maximum array size. So if we have met the other ape before, and we're looking at the honour values, 871, is the ape that we've met higher or lower status. And if they're higher status, then we might we're aligning our friendliness with them. If they're lower status, then we're becoming less friendly during chatting. The main reason for that is just to allow information to flow between networks of sort of friendly apes, I suppose. In other words, if you're less friendly towards an ape, you're less likely to chat with them, less likely to convey information from one sort to another. 885, keeping track of the location and the belief, which is just the state of the ape, timestamp as well, and set the speaking state, 895. Now, if we haven't met before, then we create a new entry in the social graph. So line 901 onwards. We're looking for the least familiar other ape, and then we're going to replace that with the ape that we've just met. So it'll just naturally tend to forget apes that it's not very familiar with over time. I'll replace those with recent meetings. So you can see line 910, we just replace the least familiar ape there.
Have you tracked any of this information through the web server?
I haven't actually at the moment, really, no. It would be interesting to do that.
It would be.
That's a dimension worth tracking, probably.
Yeah.
One thing that you can see on the web server, there is a list of the episodic memory, so you can see that an ape has met another ape at a certain time and so on. But there's no real tracking of that over time, and there's no tracking over the population either.
How you'd actually describe that graphically is a very interesting problem.
Yes, it might be tricky. Yeah. You might think of describing it as a matrix or something like that.
Yeah, I think of it in terms of a dot cloud, that basically you have dot clouds with interlinking relationships, and as you get more tight connections of the dots, they form tighter clusters, which is typically the way these things are visualized. But my interest with regards to getting all the statistical information is then having very similar to, well, the spatiality of the cognitive simulation, but a cloud formation with text and lines and ability to actually navigate around this as well and track this information as it actively happens. But it is an interesting visualization problem.
It is, yeah. The simplest type of visualization that I can think of would be a matrix where you just have number of apes by number of apes in 2 dimensions, and you just a bit flipped depending on whether one ape speaks to another. So you just have a sort of a monochrome representation of who speaks to who.
Yeah.
But the kind of representation you're describing would be more sophisticated and probably more interesting.
I think so. But no, you're right. Yours is the simplest possible. Social goals.
Right, okay. So, as I mentioned before, apes can have goals. They're only very simple at the moment. And the only type of goal that they have is really to find another ape or go to another location. So this is in fact dealing with moving to a location. So you can see that the being structure has a goal parameter, and it's extracting that at line 939, and then looking at if it happens to be a location type goal, and we're looking at the difference between the current location and the target location, line 943, 944, and then we're turning towards the goal location, line 945. So that's pretty simple, really. And line 950 to 957, this is just checking whether we've reached the destination or not, whether we're within a reasonable radius of the goal location. And if we are, then we just set the goal to none, goal underscore none, line 955. So that's really pretty simple for goals. Potentially, apes could have other goals. I don't know if you can think of any that might be useful.
You could have periodic familial gatherings. You could have various rituals or these kind of things that could come together. I think there are a wide variety of seasonal or potentially, for example, it would be to do with various feeding things. I mean, if there was modelling of fish or things like that, then the seasons affect that. And there are a wide variety of things that actually could be put in as goals. Even, for example, various birth rituals or a variety of things. I mean, if, the kind of gathering of tribes around birth rituals or these kind of things. So,
I think all of the above, really, yes.
Yeah. A wide variety of possible goals.
Yeah.
So, Bob, this has been wonderful. I think we'll probably need to get you back on to do some kind of overview, although the complexity of this has been relatively great, but the web server implementation is considerably more complicated. So maybe in the next version of the source, when some of the things that we've talked about have been answered in a kind of fuller form, maybe we'll have you back on Ape Reality to talk a little bit more about the web server. Is there anything else that you'd like to talk about within the Universe directory before we conclude this extended Ape Reality?
I don't think so. I think I'd just say, in addition to the social aspects, goals, drives, things like that, probably the two main other areas that I looked at were the land operator, and also the web side of it, the web server side, web.c.
Terrific.
So I could probably cover those in another podcast maybe at some other time.
Very good, very good. Yes, I think you've given, just in terms of the density of information, there's been a lot that's been passed on, and I know I've had feedback from various listeners that have, through previous source walkthroughs, gone through in parallel and gotten a lot of feedback. Even people that haven't had the source code in front of them that have gotten a lot from it, and I think this will be one of those. So, Bob, I'd like to thank you for chatting today on Ape Reality. It's always a pleasure.
No problem.
I look forward to having you back on shortly. Thank you very much.
Bye, Tom.
See you.